Hi guys, now we are going to discuss the first step of cellular respiration, that is glycolysis. So glycolysis is an anaerobic process. So it is a common step for aerobic as well as anaerobic respiration. So glycolysis occur in cytoplasm of the cell. Rest all processes like Krebs cycle and oxidative phosphorylation that occur on mitochondria, but glycolysis always occur on cytoplasm of the cell. So glycolysis, the pathway consists of 10-step process. So let's discuss the first step. So the glucose is a 6 carbon compound, formula is C6H12O6, and it is converted into glucose 6 phosphate, means one phosphate group is added here, and who will give the phosphate group, that is ATP will give one phosphate and convert into ADP in presence of enzymes hexokinase. All the enzymes I have written in red color. So hexokinase. So glucose is converted into glucose 6 phosphate. Next step, let's come the second step. Glucose 6 phosphate will convert into fructose 6 phosphate, that is it isomers, and that's why the enzyme is isomerase, and here no phosphate group is added, so there is no conversion of ATP to ADP. Next, the fructose 6 phosphate will convert into fructose 1,6 bisphosphate, means another one phosphate group is added here, that's a 1,6 bisphosphate, and here ATP is converted into ADP in presence of enzymes fructokinase 1. So now the most important step of glycolysis, here fructose 1,6 bisphosphate will split into two compounds, that is dihydroxyacetone phosphate and glyceraldehyde 3 phosphate. Remember here, up to here glucose is 6 carbon and fructose 6 also 6 carbon compound. Now what happened, this will dissociate in presence of enzymes, the most important enzymes, that is aldolase. It will convert into two compound, that is 3 carbon compound dihydroxyacetone, another 3 carbon compound, that is glyceraldehyde 3 phosphate. Now come to this glyceraldehyde 3 phosphate will convert into 1,3 bisphosphoglycerate. Here also 3 phosphate, here 1,3 bisphosphate, one phosphate group is added, but remember here the one phosphate group is coming from inorganic phosphate, that's why I have written PI, inorganic phosphate, that denotes PI. Now what happened here, this NADH, here oxidoreductase and process occur, oxidation reduction occurs simultaneously. So NADH will oxidize and it form NADH2, means NADH2 is oxidized and NADH is reduced, so that's why it is called oxidoreductase. So NADH2, or we can write NADH plus H plus we can write. So now 1,3 bisphosphoglycerate will convert into 3 phosphoglycerate. Now remember here 1,3 bisphosphoglycerate, here 3 phosphoglycerate, means one phosphate group is given. So here our energy conservation steps start. Here we are spending ATP, now here we are gaining ATP. So ADP, that is adenosine diphosphate, will gain one phosphate and convert into ATP, adenosine triphosphate, that is our energy source. Now in presence of enzyme phosphoglycerate kinase. Now next 3 phosphoglycerate, what this 3 phosphoglycerate will convert into 2 phosphoglycerate in presence of enzyme phosphoglycerate mutase. Now this 2 phosphoglycerate will convert into phosphoenol pyruvate, one enol group will be added in presence of enzymes enolase, and here water will be released. Now the last step of glycolysis here, that is glycolysis, that is glucose in converted into pyruvate or pyruvic acid. So phosphoenol pyruvate will convert into pyruvate, and here also one ATP will gain, means ADP will convert into ATP. Next I want to say one thing here, one glucose will give 2 pyruvate, 2 pyruvic acid. Now one will come from this fructose 1,6 bisphosphate converted into glyceraldehyde 3 phosphate and give pyruvate. Now second pyruvic acid will come from fructose 1,6 bisphosphate converted into dihydroxyacetone. This dihydroxyacetone phosphate will, this is interconvertible, so this will again convert into glyceraldehyde 3 phosphate, and the rest all step are same, and we will get the same 2 ATP, and here 1 NADH plus, and next one pyruvate. So here we can conclude that glucose, one glucose will give 2 pyruvic acid. Now let us discuss about how much ATP we get in glycolysis. So in glycolysis we gained 2 ATP here from glyceraldehyde, next 2 ATP here from dihydroxyacetone, converted into again glyceraldehyde. So total 4 ATP we gain. But remember, we have spent 1 ATP here, 1 ATP here. So next our net gain, that is net gain, will be 4 ATP minus 2 ATP, though we have spent 2 ATP here. So in glycolysis process, one molecule of glucose will give 2 ATP. That's it. One molecule of glucose will give 2 pyruvic acid. Net gain will be our 2 ATP. Next, further, we didn't discuss about NADH. So one NADH, remember, one NADH will give 2.5 ATP. So here we will get 2 NADH, one from glyceraldehyde 3-phosphate, another one from dihydroxyacetone phosphate converting to diglyceraldehyde 3-phosphate, and we will get 1 NADH, means total 2 NADH will give. 2 NADH, that is 2.5 into 2, we will get 5 ATP. So on a total, when we will see, one glucose will give 2 ATP and 2 ATP directly and 5 ATP indirectly, that is in a form of NADH2. That one will encase the ATP in the 4th state of cellular respiration, that I will discuss in the further video, that is oxidative phosphorylation. We will get the NADH, how converting and how will convert NADH to ATP. So this is the new recently, if we will follow 2-3 years back book, they will give 1 NADH will give 2 ATP. But if you will follow the last 7-8 years old edition, you will follow, they will give 1 NADH will give 3 ATP. Next we will discuss in Krebs cycle also, we will get FADH. So FADH, in the old book they will say 1 FADH will give 2 ATP. But recently what is newly discovered, that is 1 NADH will give 2.5 ATP and 1 FADH2 will give 1.5 ATP. Remember this. And we will prove it in the 4th step of cellular respiration, how 4 hydrogen atom will be given and 4 H plus will be given to produce 1 ATP, and we will prove it how 2.5 and we will get 1.5 in case of FADH. So that's it guys, this is the total summary of glycolysis. We get the net gain is 2 ATP and we get 2 NADH, that is 5 ATP. So total 7 ATP we will get in glycolysis through one glucose molecule. That's it. So I hope you like this video. So please don't forget to like and subscribe my channel, and my next video will be on Krebs cycle. Thank you.